Around IT in 256 seconds by Tomasz Nurkiewicz. Episode 14. Static, dynamic, strong and weak type systems.
When choosing or learning a new programming language, type system should be your first question. How strict is that language when types don't really match? Will there be a conservative, slow, and annoying compiler, or maybe a fast feedback loop, often resulting in crashes at runtime? And also, is the language runtime trusting you know what you're doing, even if you don't? Or maybe it's babysitting you, making it hard to write fast, low-level code. Believe it or not, I just described static, dynamic, weak, and strong typing. Languages with static typing are quite conservative. If you have a variable that's known to be an integer, compiler will prevent using it in another context. Integer cannot be interpreted as a date, string, or an object. If a function expects a certain type, compiler will not let you pass a different one. Statically typed languages catch many bugs at compile time, so you can avoid excessive test cases or manual testing. Moreover, types help navigating code, so static typing is preferred in large, complex code bases. On the other hand, when prototyping or writing one-off scripts, static typing is annoying. Examples of statically typed languages are Java, C, C++, C#, Go, Rust, and of course Haskell. In dynamically typed languages, the compiler is much less strict. Passing a number where an array was expected? Sure. Assigning a lambda expression to date? Of course. Well, these are most likely bugs. However, some languages and runtimes will do their best to run something. For example, they may coerce a single number to an array with one element, or assume that a lambda expression, when executed, will return a date. These languages are quite liberal to allow fast development, fast compilation, if any, and fast results. If you make a mistake, it's caught at runtime and you can quickly fix it. The lack of type information in the source code makes it a little bit harder to maintain dynamic code bases. But writing is much faster. Examples of dynamically typed languages are JavaScript, Perl, PowerShell, Ruby, Python, and Groovy. Also Smalltalk, the father of object-oriented programming, and Lisp, the father of functional programming. Now let's talk about strong versus weak typing. Contrary to some beliefs, strong does not equal static. As a matter of fact, these type systems are independent of each other. There can be static but weakly typed system, for example C and C++. Also dynamically but strongly typed languages are possible, for example Ruby and Python. Okay, so what's a strongly typed language? The definition is kind of blurry, but in general it's a language where types are strictly guarded even at runtime. For example, Python is dynamically typed, but trying to add string to int yields a type error. The same goes for Java. Even if you somehow hacked around the type system, the runtime will discover it. Interestingly, C# is sometimes referred as weakly typed due to unsafe blocks. So what is weak typing? In this situation, the runtime is very liberal and allows generally unsafe but useful operations. An example would be C that supports arbitrary casting. Turns out, viewing a floating point number as a sequence of bytes or a string is a very powerful but also dangerous feature. Another example is pointer arithmetic, where we can traverse memory with very little safety mechanisms. Such arbitrary memory traversal is precisely what good type systems should prevent us from doing. Weak typing has very weak definition. Typically, languages like C, C++, JavaScript, and Visual Basic are attributed to this group. That's it for today. Thanks for listening. Bye!